Good morning, wonderful attendees. I'm your host, Dalvinder Kaur from lovely Professional University. Get ready to dive into today's topic that is discover the future of architecture through digital applications. Before we proceed further, allow me to introduce the experts of the day. Professor Tara Singla, Professor HOD School of Architecture, lovely professional university. With over 20 years of experience in this field, she is the founding member of I- Ideurge Architecture, a firm dedicated to innovative and sustainable design solutions. So now I would like to introduce Mr. Rick Ash. He's the alumni currently serving as a senior BIM architect at VBS. Mr. Rick specializes in architecture, interior design, and 3D visualization. With a passion for blending art and technology, he strives to create innovative functional design and more. Before we proceed further in today's session, I would like to request everyone for any questions you can write in the chat box or in the Q&A box, and same will be addressed from my side in the end of this webinar. Now I'm going to hand over this session to our experts, Professor Tara Singla and Mr. Rick Cash, and it would be an absolute delight to listen from them. Over to you both.
Thank you, Dalvinder ma'am. I am elated here that we are starting this new session of webinar series with our alumni now. Rick has been a wonderful student, and I remember teaching him was a sheer pleasure. Today, he has reached a phenomenal height in his career, and he's a BIM expert. And I would like to say that BIM is actually revolutionizing the industry today. It is providing a framework for smarter, more integrated, and a very sustainable design practice. So, whether you are a student, a prospective student of architecture specifically, or if you want to be, just associated with sustainability and teamwork in a better way, I think understanding BIM today with its multifaceted benefits and challenges is the key to navigating the future of architecture or any other field that involves teamwork and fabrication. So, on that note, and without wasting any time, I will here call my dear student and an alumnus of lovely professional university to please enlighten us more on this topic today. Welcome, Rick. Welcome back, I should say.
Okay, hello everyone. So myself, architect Greg Ash, and so as ma'am said, I've worked for a lot of companies, and right now I'm working as a BIM architect at VBS. So I have been delighted, and I've got the opportunity to work for big projects in USA that includes mostly hospitals and MOBs. So what I have learned that BIM is a way of working which has been introduced in this era of AEC industry, and that has revolutionized the way we construct things. So this presentation is going to be about that. So we'll talk about BIM. So BIM, the definition of this, the abbreviation of this, it is Building Information Modeling. So it is a collaborative digital workflow, and what we do is this set of way in which we deliver the process. So okay, we'll talk about the structured workflow, how it actually happens. But I'll kind of go through different problems. So in order to explain the statement, I'll try to show you what actually happens in site if you do not use BIM. Then we'll try to understand BIM through those processes, and we'll try and define the workflow, and then we'll look at some case studies that how BIM was used to kind of make those things. Okay, so we'll talk about some problems. So if you see these pictures, so what happens is that usually architecture is something in which we work as a team, but Sometimes due to miscoordination or misalignment, things like this can go wrong. If you can see, there's supposed to be a corridor, but columns are coming in place, and it can be a disaster. Again, if you see for this, this in this image, so there's a vent going right through the window, and it's kind of problematic. The window is closed. We cannot access this balcony, beautiful balcony. It's a mess. Again, when it's not just about aesthetics, but construction of building also includes a lot of technical things, like maybe services like HVAC and structural drawings. These coordinations are pretty difficult to do on site when you do not have proper visualization before. So it might lead into a lot of clashes. Again, if you can see this image, it could have been a very simple fix, but as you can see, there was some last moment changes, and this led to a ramp that actually leads to nowhere. So it's kind of a mess. Again, if you look at this picture, so we have an escalator that's going, but if you can see the ceiling, it's not coordinated at all. So it's kind of problematic when you kind of try to walk over here and you have the ceiling, stop your head. Or if you see this picture, for example, this woman who's trying to walk, but where would she walk? The things are not coordinated at all. Again, for this image, if you can see, so the door, it leads to nowhere at all. So like problems like this can often happen. So let's do an example. We can, if you are whatever, wherever you're sitting, you can list some elements. You can see some elements around you, and let's say you can see tiles, you can see fan, you can see maybe the wall around you, you can see a lot of different elements around you, right? Now here's the thing, when we are trying to construct a building, we need to document and keep those information in a certain place. So let's give an example of computer. Let's say a computer goes wrong, something happens to my system. What do? I have a manual. I can go and read that manual and I can fix that. Okay, I know these are the parts that needs to be fixed. So I can go and fix those particular, whatever things have gone wrong. Maybe keyboard, maybe the keyboard has gone wrong. I know that, so I can just fix, a couple of keys and this and that. But for building, I don't have a manual for a building. You see, in building there are a lot of components. You have columns, you have bricks, you have flooring, you have electric appliances. There are thousands of things, and usually what, because there are a lot of different teams who are working in a particular building, so they have their own set of drawings, then their own set of like way of working, and mostly what happens is that things are not collaborated. They're all scattered at different places. So it's very difficult to kind of accumulate all those information at the same place. So, tomorrow when something goes wrong, you do not know where to look for the solution. There are information scattered everywhere. So this is actually the problem that has been happening in this particular industry for a very, very long time. So these are some of the points, that final design is not in a unified location, because there are a lot of different domains that are working, and people are working on like they have different files, if everything is in a different place and they're not in the same location. So it's difficult to access one single final file. Then you have collaboration, the new real-time tracking. So people are working remotely somewhere, things are not linked to each other, so it kind of becomes a little difficult to collaborate and stuff. Then you have people also make 2D drawings and 3D drawings which are not in sync. So then again, schedules. So as architects, what we do is okay, let's say for example, you are going to a restaurant, okay, and you have ordered some food. So let's say someone orders like XYZ food, and we are like, okay, the bill is getting generated. But let's say mid meal, you've ordered some more food, and the bill is not synced. People do not know, or someone has cancelled an order, but that bill is still there. So it kind of becomes a mess with the bill, and nothing is synced. It's kind of similar to that of buildings also. So you see, while designing, a lot of things gets changed while the design is actually happening. So what happens is we also need to generate the schedules and all the export the BOQs and stuff like that, which if not linked to the actual current design stage might lead to disaster. So yeah, again, in the legacy tools that we used to follow, like AutoCAD or stuff like that, they are not capable of storing the information that I'm talking about, like the schedules that I talked about, or things like that. They do not have the capacity in it. So in recent times, we have come up with new tools that could actually help store these information. So it's a little detailed thing, but I'll try to break it down for you. So designing the construction process could be broken down into these four categories. So you have this design phase, then you have this construction phase, and then you have the management phase. So once the building is constructed, for example, if you go to a big hotel, so you see that there's a management that actually sees that, okay, everything is in the right order or not. For example, some maybe the HVAC is not working, some AC is not working, so the management will go and have to see, okay, there's some problem with some piping or stuff like that. Then have to report to the engineers or whoever is working, and then they'll go and fix that. The management, it needs to be there. And then finally the renovation. So when let's say the building is old, you have to break those buildings. So that's the life cycle of an entire project. That what usually happens. So with all these phases, we do have problems. Like in design, we do not, as I talked about, we don't have proper collaborative tools. In construction, mostly what happens is that there might be some design changes, and that is not reflected in the drawing. And for that, there could be some delays and some coordination issues, or also some waste that can be generated, which is not a sustainable practice. So you see, when we talk about sustainability, most of the times we overuse a lot of materials which is not required, and that can be actually can be managed. And then sorry for the background noise. Okay, then again, as I talk about management, we do not always have this information that we require. Like as I talked about the HVAC, something can go wrong and we do not know where the pipe is leading to. So how do you track those problems, right? And again, renovation. So now we'll try to understand the concept of BIM and how BIM tries to solve these problems. So again, it's a little bit technical, but again, we'll try to understand this. So there are two different ways of modeling. The first idea is geometry modeling. So in this type of modeling, what we usually do is we are mostly constructing the 3D geometry, how it would look like. But in information modeling, we are not only modeling the 3D geometry, but we're also modeling additional information associated with the element. So I'll explain this thing to you. So again, for geometry, we have these tools that allow only 3D geometry, like SketchUp, 3ds Max, or Blender. They allow 3D geometry, but Revit or ArchiCAD, they actually allow you to have information embedded in the inside the model. Okay, so this might help explain some of the people who are planning to kind of come into this field. It's a bit technical, but I'll try to break it down for you guys. So when we try to model an element in different tools, so if you see this image, we do not know what this image actually is. It could be a wall, it could be a glass, it could be a book. I don't know. It's a rectangular piece. It does not really have an information associated to it. Again, if you see this image at the center, we can see that it has some brick textures on it, but that's the only information we have. We do not know the height of it, the quantity that it's there, or it could be anything. And lastly, there's another white image. It could be a block of ice, it could be anything. There's no information that I can generate from these three images apart from some textures or something like that. But if we use BIM, so let's say this is an example of a small area or a cafe that we have. And let's say I use this wall, for example. So the wall, when you construct a wall, you actually have multiple information that you can embed inside this project. So in a way, what happens is once you construct an element, you can later on extract all this information. And let's say something changes. So you change a wall. The information automatically adjusts accordingly, which actually saves a lot of time, and also the schedules, everything is coordinated automatically. So you save time, you save resources, and you kind of we are helping everyone. So again, it's not just for walls. It could be for doors. It could be for any small, even those glass mullions that you see, the storefront mullions that you see. It's for everyone. So all the information are all embedded inside this particular um, tool. So what this BIM model actually does is it actually helps you to kind of contain the information. So you have the information, it's kind of a container, and you can add information, and then you can also extract information. So that's the kind of the idea of this BIM model. You can add information and then you can remove information as per your requirement. So again, this is one of the examples. So usually what we used to do in previous stages were we used to do 2D drafting, and then we would model that in this in this environment. So but then there's no coordination. So if you have something modeled already, then you have to go back and change that thing in the 3D, and that might be a little difficult to track. So if you change something in one place, you have to again do the rework in a different place. So tracking these things is becomes a really big problem. But in BIM, when we use BIM, it kind of we have everything in a single place. So you have your the model that you have, you can extract information from that. So you don't have different places. Every information is stored in a single area, and from that you can extract the required data that you're looking for. Someone wants to work on the BIM model, I mean the visualization. So you can see here, we can see some visual data, or someone wants to talk about window schedule. So you can see we can extract schedules from this particular model only, and whatever changes you do here, it's getting reflected automatically in the schedule as well. Also plans, sections, whatever details that is required in building construction, every single thing is coordinated. And the best part about BIM is, you see, we were talking about teamwork. So architecture is a domain in which you will be working with thousands of people continuously. So it's important to have a platform and have an understanding how teamwork actually helps. So in BIM, you kind of have this environment in which you can link different models into a same place, and you can work in the same collaborative tool. And it's not just in one office. So let's say you're working with different offices. So we have different models, and we can sync the same model in the central model system. So what happens is that you can access all everyone's work. So for example, there is a structural team, there is an MEP team, and then there's an architectural team. So you have all the different teams who are working, and everyone can work on a single platform. So like the issues like coordination, they get really, really reduced in this stage. So then there are different levels of BIM. So people, they usually start with very basic drawings, for example like 2D drawings, and then they go to 3D, and then they collaborate in 3D, real time. And then you also have your full integration, in which in like what we do in bigger buildings, that you have all types of sustainable data, 4D simulation, and everything that's happening continuously in real time. Okay, talking about dimensions of BIM, then again it's something a little technical. So what BIM actually does is as I was talking about 3D modeling, but this technology has revolutionized the way we see model, and we have more than 3 dimensions now. How is that happening? So 3D modeling is the geometry that you can see, but after that, we also have 4D modeling. So for example, time. So, for example, someone wants to understand that how long will this building take. Okay, I'll give an example. Usually you go to a restaurant and you might have ordered some food, right? And you might expect like, "Bhaiya, kitna time lagega? How much time will it take for this dish to get prepared?" And someone says, okay, 10 minutes, 15 minutes, half an hour, whatever. But when you're also designing a building, you might also want to know, like, oh, okay, like, how long will this building actually get built? But it's kind of difficult to track all this information. So, BIM actually allows you to keep track of all this information, and we can actually see, okay, timeline. Okay, this much part will take this much time and stuff, so and so. So we have all this simulation. Again, costing. When you go to a restaurant, you ask people that, okay, how much money will this cost? You see a menu, right? But in building, it's customized for you. So everything can be of different price. Even your neighbor's building will be of different cost than your building, right? So BIM can actually keep track of all of these data, all of these monetary transaction that is happening. So certain elements can be of a different cost, and we can manage all the information in the same model. Then you have sustainability. So not only are we talking about the cost in here, but we are also talking about how to save materials. So when you have a coordinated model, what you do is we can see that, okay, some elements are extra and we do not might need construction of these elements. So you can kind of cut these costs at that place. So sustainability is also another parameter that can be used in BIM. Then we have 70 BIM element, which is facility management. So I just talked about an example in which you have tiles in your building and you have HVAC and maintenance. So how do you maintain these things? BIM actually allows you to keep a track of all of these kind of elements that you are used in your model. So for example, you have a tile which is broken and you do not know what manufacturer the tile was or what thing is that. So in BIM, it actually allows you to keep a record of all of the information that you have actually added while you were modeling. And you can go back and see in the same place that where what tile was there. Or for example, fan or maybe some plumbing fixture. So you don't have to look at different places. Everything is there in a single model. That's how you can actually utilize the single model and use extract data in later phases. Finally, we have risk management. These are new dimensions of BIM. As technology is increasing, we are also adding new dimensions and we are trying to see how risk can be mitigated, and we try and see if things can be automated and prefabricated in a certain way so that installation happens quicker and in a much safer fashion. So risk management is also a new dimension that has come up. Then we talk about some workflow. So as I said, it's not a software, it's more like a workflow. So we have design tool that actually leads to documentation. Ultimately, we as architects, it's our responsibility to, like make some design and then finally make valuable document out of it such that it can get built. So we have different stages. We talk to clients regarding briefing. We understand the brief. Then we have design phases. Design phases can be in different parts. We have schematic, we have design development, then we have construction documents. Then it finally gets constructed in stage 5. And finally, we hand over all the data that whatever we have to our clients. So we'll try to understand. So let's say you are a client and you have a requirement. So you say that, okay, I want a hotel, or let's say I want a hospital, for example. So when we are making a hospital, there are a lot of people involved. There are a lot of vendors involved. There are a lot of stakeholders who are going to be a part of this agreement. And it's our responsibility as architects to keep a track of all of these people who are going to be working. And also, we have to give a proper set of roles and responsibility to all of these domains. So this stage of BIM actually encapsulates all of these information. So everyone knows what their job is and no one is working less or working more. Then comes design development. So you see beautiful renders on buildings. So when you go in apartments, you can see like posters and stuff like that. So no, that's something that's what we talk about visualization. So in that, we as architects, we develop a lot of drawings and designs and stuff like that, and we render those things, and we talk to clients and ask them, okay, do you like this design? Are there any changes that you want us to do? So this stage encapsulates those elements where we have the liberty of where we have all our liberty, and we design things whatever is as per the client's requirement, or as per the surrounding and as per aesthetics. We take measure of all of those things, and finally we come up with a render. But that's something for the clients. But for developers, for those who are actually building this thing, we need drawings, and we need detailed drawings. So for that, this next stage, as architects, we'll be further making the drawings in a more detailed fashion. So we have more spaces. We understand spaces. We understand they need an office room, they need a toilet, they need a staircase, stuff like that. And how much area do we allocate for each and every area? So we are now addressing the bigger picture. We have broken them down into different levels, and now we are addressing each and every floor, and we are also segregating spaces. So we are giving a more detailed fashion, or design in a detailed fashion. Then comes drawings. So you see, we can generate different types of drawings just from the same information that we had. So if, let's say, usually what happens in design is that when we are working and in mid phase, client will come and say, oh, you know what, we do not like this thing, we want some changes and stuff like that. So in usual practices, what happens? People would have to make every single changes manually, be it 3D, be it 2D, be it coordinating with the HVAC people or structural people. So that becomes a lot of tedious work and time consuming, and it kind of delays the project. But in BIM, what we do is we have since everything is collaborated, so whatever changes you do in one area gets reflected in all the domains. So you don't have to worry about clients changes. Whatever changes are there, it's reflecting automatically in all the drawings. So finally, when we are constructing, so usually again, as I said, you might want to build a wall which is 10 feet wide, but inside you see we don't have 10 feet wide space. It's a 9 feet area that can be built. You don't have 10 feet length. So how do you communicate these kind of problems? And it's just one instance. There are billions of instances happening, at every single second. So how do you kind of keep a track of all this information? So BIM kind of allows us to have a platform in which we can keep a track of all of these information. So this was something about when we are trying to address all the different stakeholders that there are problems. So we can go at a single place and see, okay, these are the problems, and everyone knows. It's not like we have to address everyone. Everyone knows where the problem is, and then we individually can take care of whatever things are there. And lastly, facility management, which is managing all the elements. There's a new technology in BIM, which is a very interesting part, which is called scan to BIM. Now, let's say you want to get your house renovated. Okay, it's a build. It was built when maybe 35, 40 years back, and you don't have BIM. You never had BIM at that time, but you want to make sure that whatever things you are working on now, all of them are coordinated properly, and they have the required information. So usually what we used to do is we used to manually go on site and measure every wall and every room and everything, whatever we can see, windows, doors, everything. But when you have manual, like human input, that would always lead to errors. And when you have errors, that would again lead to further wrong documentations and things like that. So in scan to BIM, what we do is we have a system called point cloud, in that we have a machine that can actually scan your actual building, whatever. So you can see this image on your left, that's a scanned building. So it can capture all the real elements which is there present in your building, every single cracks, every single whatever problems are there, everything gets captured in this particular scan, and that can be captured inside a software called Revit. So we can capture all the point cloud, and then we can put it in Revit, and then we can draw over it. So it becomes very fast to kind of see all the information. You don't have to go in the building, click photos and things like that. Every information, detailed information is there present with you. So there's another example of building. So there could be not just small houses, but even bigger buildings. So when you have big facades and things like that, how do you capture these things? So a lot of times I see historians who are people who are working with old monuments and restorations. We often struggle with maintaining the actual geometry that was built. We can sketch, we can make dimensions, but that's not accurate, and there could be thousands of things happening. How do you keep a track of all things and do it faster? So BIM, what BIM does it acts, I mean, the scan to BIM does it. We have all the point clouds of all the areas. So point cloud, as the name suggests, we have thousands of points. The laser that we have, it kind of focuses on the building and captures wherever it's hitting back. So we have a data of all the points from where it's hitting, and that all the points we capture and we call it a cloud. So it's called as a point cloud. So we capture this point cloud in Revit, and then that's how we can build around it. So it's a very fast and a very convenient way of capturing as-built drawings. It's again a little complicated thing. It's something that we do when we work in models. So we often in BIM, it's a terminology that people can often work on different levels and different details. So as you progress, as you are more mature, you can model different LODs. So that's about LOD. So we'll talk about a couple of tools that is very popular. Like we have Revit, we have ArchiCAD, we have Rhino. Then people also in today's time, we are mostly into AI. So AI and automation has become a very powerful tool. So there's something called Grasshopper. There's a tool called Grasshopper that can actually capture parametric designs that we see, and we can compute them using ChatGPT. So ChatGPT can have some data which can go inside Grasshopper, and from that we can generate geometries out of it, which can go in BIM. So it's a line of software that we use, and everything is linked to each other, and we can then use Enscape or Twin Motion to see the beautiful renders that you see, or the big posters that you see. So these are some of the tools that we use. Now we'll talk about some case study. Okay, so this is one of the buildings that I'm working on right now. It's in North Carolina, USA, and it's a company called Atrium Health that's working on this. Now it's a very big project, around 1,70,000 square feet of area. And what challenges we face while constructing this particular building is that you see clients, they came up one time, we had the designs final and everything was done, and suddenly they came and told us that we are out of budget, and we might have to shift certain area of the building, and we have to construct them later on. And so we would want you to remove these parts and then give a schedule again, and do stuff like that. Now imagine if we had to do that everything in legacy tools like AutoCAD and Excel and everything like that. It would mean designing a complete new building, which would take the same amount of time that it took us to make it from that time. So it took around 1 month or few months. But because it was all done in BIM, we could do that in just 2 to 3 days. All the new options that they were looking for, we could actually extract those things and add all the things that they were looking for. And everything, all the schedules, all the drawings, everything was done in 2 to 3 days. And it was all approved, and we were good to go again. So that's the use of BIM, that we are managing time, and we are also not wasting resources of clients and other things. So that's one of the most beautiful part of BIM. Okay, so that was about it. So I would like to have some questions if you have regarding the
Yes,
presentation that.
first of all, yes, we do have a lot of questions. I am getting a lot of questions on my WhatsApp already.
Okay, great.
Thank you so much, Rick. Your presentation has been very, very insightful, and I should say I'm proud of my student. Okay, so coming to that, what a fascinating presentation Rick has given us about building information modeling. I would actually like to add two more dimensions to what you have added. You have said that it's an 8D BIM, but I would like to add two more dimensions and say
Yeah.
9D is the scanning thing that you told us about renovations and everything, and 10D is, of course, AI. Now, an interesting story about BIM and AI is that people think that it is relatively new. They feel that it is something which has just come up. But I think there's a story that it actually has its conceptual roots. The facts emerged on BIM in 1970s,
Yeah,
and
yeah.
that is when AI also started. So I think it is the most foundational formats of AI that we have running around in the AEC industry now. And it is actually very helpful. But my question to you is today is that people are unfortunately not ready to get rid of AutoCAD. Can you answer that question in terms of India, Indian students, and Indian pedagogy? Yes.
I am very happy that this question came up, and I'll tell you my story regarding this. So I was not a BIM guy in initial days. I was working mostly on SketchUp, AutoCAD, and things like that. And I remember once when I went to an office of mine, like in internship, I was talking about BIM. Like I was telling them, we can let us work on Revit because we can extract. For me, Revit was a tool that can be used to extract plans and elevation. That was the only thing for me. So they said that
Yes.
no, 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 we are architects, we should do everything manually. We are designers and we draw and stuff. I was like, okay, okay, you make your point. But as I went further, so again, there was another office of mine that I was working on, and I was working mostly on the collaboration drawings. So
Hmm.
so the space was already there and planning was happening. I was supposed to overlook the structural drawing as well as the MEP drawings and then coordinate that with our design. So I
Hmm.
realized even a small fraction of change in a column or whatever happens would lead to thousands of drawings. And I was like, this is not the right way, this is not happening. So
Hmm.
I knew that okay, Revit could do that, but that's when I kind of forcefully came into Revit. But the reason why people are still not doing it because BIM as a tool is a little difficult to start with. So for
Yes.
example, as I said, there are a lot of different platforms and a lot of different so you have Naviswork, you have Revit. Revit itself is a little difficult. It's not that easy as compared to SketchUp or Rhino or any other tool. BIM is a different way of working. So as I said, it's an information modeling, not a 3D geometry modeling tool. So you're not
Yes.
just modeling the wall, you're also simultaneously adding information into it. So people
Hmm.
often think that we are wasting time. For example, I tell someone to make a door. Making a door in Revit would take a little bit more time. But
Hmm.
once you make a door, a proper door in Revit, you
Hmm.
can it's param. Okay, by the way, it's a parametric modeling tool also. What it means is,
Hmm.
let's say I make a door and I have given a parameter of 3 feet. Let's say the width is 3 feet, but I can change the parameter later on. So I can
Hmm.
make it
Hmm.
4 feet, 4.53. I can make it any number, any type of door,
Any.
whatever size I have. So that's the best part about BIM. It might take one, you can make just one instance and then you can replicate it as per your needs. You can make different sizes of it. So people are not really aware of this thing, to be very honest. And
Yes.
that's where when you start working in BIM or in Revit or any other these kind of tools, they kind of feel, oh, it's too much of work, and let's stick to legacy tools. And that's one of the reasons why it's not happening in India. It's still not happening. But
Mm,
in USA, UK, BIM is mandated. So any
mm,
building that we do, it needs
mm,
to be BIM compliant. So
mm.
what happens most of the times, I see projects that are coming up. People are designing things in SketchUp and AutoCAD, and then they're giving BIM modelers. We have all the drawings. Just make a BIM
Yes,
model out so
yes,
that we can
yes, yes.
pass it.
I, I totally agree with that, and that's the funny part because
Exactly.
people do not know that if
Yeah.
you are doing everything in BIM, your productivity is
Hmm.
increased by 70% almost. And
Yes. Yes.
again, I come back to, your thousands of drawings and things like that. If you're going for a paperless office, I think BIM is the way
Hmm.
to go. And also,
Right.
if you want to reduce the energy consumed, the resources consumed, so what would traditional offices in working in developing countries do? They would say, okay, let's hire, four draftsmen to do something, which maybe, like you might hire diploma holders, interns, pay them a salary of 15K, 20K, but you would not hire two BIM professionals and pay them a salary equivalent to those. You'll say, no, no,
Yeah.
no, not. It's not lucrative. But people are not able to break that shell. People are not able to understand that the current workflow in India is working in a silo. It is you are working in your separate silos. The engineers, the structural engineers, maybe a graphic consultant, maybe the architect, interior designer, furniture guy, all of them are working separately, and that is costing them immense amount of time and energy. This, I think, all the clients also need to appreciate that for this whole paradigm shift to occur, you actually have to understand and make up your mind at the start of the assignment. This actually
Right.
brings me to my second question. We were talking about legacy tools and we are talking about geometry modeling. And from there, we are going to information modeling, which is highly technical. And we're talking about softwares like Revit, ArchiCAD, and stuff, etc. The point is, when small firms come to use of it, a small firm is when I maybe just started off like 20 years back. I had smaller projects. I had, a small office. We still do small projects, but the way of working has changed, right? Because now that you've worked on bigger projects, you know how smalls can be, expedited and you can give a better result. But when you start working just at the outset of it, you are actually looking at smaller projects. So in a smaller project, the client is also a bit, he's anxious, he's scared, maybe he's also doing it for the first time. So he'll go a lot of back and forth on issues. Like you are saying that you've done, in the case study, you have also gone back and forth on the hospital thing that now we don't have money, so, let's redo some of the parts. And when this happens to a really small project, the architect feels that no, BIM is not the right way to go. ये तो हर तीसरे दिन he is changing. So I don't want this to happen. So what answer do you have for those clients or
Yeah.
those
Again.
architects and designers?
Okay, so it's a very beautiful question, and I have two answers for this actually. The first answer is let's rewind the thing. Let's look it backwards. You have the structure built. You have let's say 20 years back, like it's a small house we are building, and everything is done. And after a certain time, you want to let's say do some renovation or stuff like that. So for
Yes.
that, actually, BIM helps you at that phase. Now you have
Hmm.
all the drawings and you have all the updates with you, and
Hmm.
you can actually go ahead and make the changes in the same model. And there's also something called phases in BIM. What
Hmm.
phases does is, let's say you are demolishing some part. You are okay. When you are in a reconstruction, a lot of times we have quotations for demolition. We have
Hmm.
quotations for how much part has to be kept intact and things like that.
Hmm.
So that part is also a little difficult to get done in legacy tools like, or we can do it, but it's taking a little bit more time as compared to Revit. Revit can actually do it
It's very
very
manual.
quickly.
The process is very manual in legacy tools. I would
Yeah.
probably give the drawing to somebody, then ask somebody to calculate, and he would also be using the
Yes.
legacy tool. But the calculations cannot be, they can't be certified that they are correct because he is
There
somewhat
is
using
no.
some manual calculation in that.
So actually, the calculations is basically what mostly we do is we need volumes, to be honest. When we are
Yes.
trying to break something or make something, the biggest thing that we as architects need is volume. You have the
Hmm.
volume, multiply with the number, and you get the cost. Getting the
Yes.
volume is the most difficult part. So
Hmm.
Revit can help you with the volume part in an instant.
Hmm.
So that is where you have BIM, because even if you're making a smaller part tomorrow, if you're working on renovation or anything or any other data which
Hmm.
might need to get passed or something like that, you have all the
Hmm.
information that you need, and you can, like, get these things done. So you can add
Hmm.
the building in different phase. So you have a building now which is in existing phase. Sorry, you're constructing it in a new construction phase. You can select
Hmm.
the model and then put it in existing phase, and then you can make the changes. So BIM keeps a track of all the elements that you have used and what are the different phases. So tomorrow something goes wrong in some floors below, you know that okay, this is the reason why this has happened.
Hmm.
So it kind of keeps track. It's kind of a record of your building. That is the reason why BIM is kind of, important, I would say. And is it? Do you have any more questions for this part, for this answer?
Yes, I have two more questions.
Mhm.
I have two more questions. Yes, the interoperability that we have spoken about, that how to break the siloed approach we have spoken about. But still, why do you think there is a gap? There is that cultural shift is not occurring. Is it the technical know-how? It is not being introduced in colleges. Is it that? Or is it the general mentality of the student to go with something which is simpler to learn and less exhaustive as a procedure at the start? So, here actually I am addressing the student's mindset that if we want to break into that and we want to say that, let's not do this because today, even I, as a head, if I tell my students that, let's not talk about AutoCAD in the first year, let's talk about BIM. They'll say, oh, no, 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 no. It's a tightrope walk. I don't want to do that. I want to start with AutoCAD and slowly and gradually upgrade myself to BIM. However, I would I would like to inform you that LPU is doing a lot of endeavors these days which involve highly technical skills, imparting highly technical skills to the students, including artificial intelligence, prompt engineering, generative AI. So only day before yesterday, I had somebody come in from Linear AI, which is a top firm in London, central London, and he was talking about giving a presentation. Mr. Pavan Singh Chahal was here for our LSAD students. So he was talking of giving a presentation to all our students. So we were chatting on dinner and I showed him the work of fourth year student. Rick, you will be amazed to know that the things we were doing before Corona, we couldn't even think of, competing and doing those things. The child absolutely mapped it to perfection. And not just that. I will tell you, I'll give you the name of the studio he mapped it to. Studio Timfu, you must have heard of in UK.
Yeah, yeah, yeah.
Yeah. So they are
Yes, I have.
excelling in artificial intelligence and they are doing phenomenal work if you look at their LinkedIn and profiles like that. So
Mhm.
they were, I think, awarded also as a content generator on LinkedIn for AI. And I picked up a reel and I just, just to gamify
Mhm.
design, I shared it with my students. I said, who does a concept like that? Who does his concept in that format? I will give him 85 to 90 marks, depending on
Mhm.
which category, how much he has achieved. You won't believe within hours, Bini, I would say 30 minutes, five groups, five groups means almost 25 students from a lot of 100 produced four reels which are exactly the same and map it much more beautifully because they incorporated other tools. So
Wow, that's beautiful.
yes, it was phenomenal, and then it's still there on my LinkedIn. I posted it like last week, and I'm getting comments on it that your kids have done wonderfully. So this is what I'm saying, that somehow the student mindset also needs to change. That
Yeah,
if the institute is there, is providing you all the technical expertise, is providing
right.
you all the, probably you also need to inspire yourself in some way, that I want to break away, I want to make this shift, and I want to jump to other things. So on that, what do you think as a student were your challenges at that time? I mean, I know it's hard to go back and think like that now, because you will say, oh, that's not me now anymore, but can you
Yeah,
share your challenges? Yeah.
yeah. So I would say awareness. Now, I think there's another part of architecture, which is the science of building. I mean, when I say science of building, is the knowledge of how, one would construct something. I know AI is beautiful and we get results. However, at times, what I've seen is that a lot of people might struggle with certain elements. But
Hmm.
LPU, when I was there, I know in building information, like in the BMC classes, we were all working very nicely on the, like all the details. So how to make things construct in real life. So what you throw me any design, I know how to actually get it constructed. So, that is another aspect of web. So we have
Hmm.
visualization, and after that, like the design phase I was talking about, and then a documentation phase. Because
Hmm.
that documentation phase is something that usually, unless you actually go inside, you might not understand. But I
Hmm.
remember it wasn't a problem for me because in LPU we really had all these internships that we had to go on, and we had a lot of different like site visits and everything that. So we were more exposed to these kind of real life problems.
Hmm.
So the next stage after visualization was getting it really built. And that
Hmm.
is where I realized, okay, you know what, yeah, these are the problems. So I wouldn't say struggle. I didn't have much struggle. I knew because I was in LPU, we already were learning about BIM when I was there. So it wasn't a very
Hmm.
big change. The offices that I
Hmm.
was working on, they did not have BIM, unfortunately. So that
Yes,
was the
yes.
only background.
Hmm.
So, anyways,
Keeping that only in mind, keeping that only in mind, today, if I tell my student who is from Punjab and I tell him, oh, you don't work in Punjab now. He say, why? I have a house in Punjab. Why will I not work in Punjab? So no, you have to go out once. You have to travel the whole world, and you have to come back to us and then say that, okay, and educate us more. That this is how it has changed. So I want actual contributions, and I'm so happy, Rick, that we spoke the other day, and it was after ages, I know, but I felt really happy speaking to you, knowing what you're doing with your work, phenomenal work. And I understand that slowly and gradually, firms like one of yours are going to bring a lot of laurels, not just to architecture, but also to India. So, so proud of you and so proud of students like you. Thank you so much for coming to us today.
okay, thank
Thank you
you.
so much to, yes, please continue. Mr. Vikash, you
Yeah,
want to
no.
say
Yes,
something to
Rick,
ma'am?
Rick wants to say a few words, I think. Yes, Rick.
Yes, sure. You can continue.
Actually, so no, I mean it was incredible talking to you guys, and I kind of got flashback like listening to ma'am, like how ma'am would teach us, and it was wonderful, like my time in LPU, it was one of the best times of my life, and I always still think about those days. I still talk to my friends, and you're like back in college used to do this and that. So yeah, I mean it was wonderful there, and it was lovely having you guys, you guys inviting me here. I mean, it's a delight, and thank you so much for this opportunity. I really appreciate this.
Rick, we are more thankful to have you, and the pleasure is all ours. And of course, I thank you on the behalf of LSAD and all our students here. Thank you so much for coming and joining us.
Once again, thanks to our experts, Mr. Rick Cash and Professor Tara Singla. If you have any questions regarding admissions, you can do WhatsApp chat with us. Our WhatsApp number is 92 985256900. I'm repeating the number. It's 985256900. And you can also write to us at admissions@lpu.co.in. So, as we come to the end of this webinar, I want to express my deepest gratitude to our experts for sharing their valuable insights and expertise with us. Your presence, enthusiasm, and active participation have made this experience truly special. Hopefully, the attendees found this webinar to be valuable and will be able to utilize the information for better decision making regarding admissions. If anyone wants to access this webinar again, they can visit our website, that is lpu.in, or can be accessed on YouTube also. Stay connected with us for future webinars. Until we meet again, with the permission of my seniors, I would be signing off this webinar. Take care and goodbye. Have a nice day.